Hi there, I'm going to talk about Heaven's Gate in this talk and briefly talk about how a WoW 64 program is created and reversing the whole WoW 64 layer by Microsoft. From this, I got some findings that is interesting could be abused in the wild. In the end, I will release two new attack methods could be abused based on this talk. I'm ShengHao, currently work at TX1 Networks, and I do this research during I'm working at SciCraft as an internship, and I have more than 10 years experience to play in reverse malware and exploit on Windows. I just wrote a book named Windows APT Warfare, basically talking about Windows hacking tricks. And here's today's outline. First, we will discuss how anti-malware working in a 32-bit mode and why we need to use this kind of a trick named Heaven's Gate to bypass this kind of potential by antivirus. Then, second, it's important for us to know the implementation of WoW 64 layer. We will share some interesting findings that could be abused from reversing findings. For example, how a WoW 64 program is created as a process. You will find there's a fixed path from 32 to 64 just inside the WoW 64 layer. Finally, you will find there's a point is there's a translator, I will call it translator, using the 64 API, anti-API to simulate any 32 interrupt. And based on those findings, we create a whole new method to abuse the whole WoW 64 layer by Microsoft. The first one is WoW Grail. It basically built a whole new path directly to code the translator we just mentioned. It can make us more easier to knock on the Heaven's Gate again, but more stable than other ones say. And the other POC is WoW Injector. It basically do the process injection, just exploit the threat snapshot in WoW 64 process. So first, we need to talk about what's the health for malware. I mean, we need to define what the health for malware on a victim install the anti-malware. So we are briefly talk about the heaps design by anti-malware. Look at the picture. This picture is mentioned by Farad in 2021 post. And this picture show a normal anti-API codes from 32-bit to 64-bit on Windows. For example, when a thread is just jumping to a 32-bit anti-ransomware thread, then the thread will walk into the WoW 64 layer. Then this 32-bit system interrupt will get translated into 64-bit. And finally, the WoW 64 layer will call the anti-ransomware thread 64-bit. So from here, you can see basically the WoW 64 layer basically is a translator layer. And here's another picture also mentioned by Farad. If there's any anti-malware program is installed on the victim, there should be a lot of hook placed on the 32-bit anti-API. For example, just like this picture is anti-ransomware thread is hook. And when any malware try to abuse anti-API like anti-ransomware thread, anti-malware will get notified in no time because it got a hook here on the API malware try to use. So, however, in a WoW 64 process, WoW 64 process basically is a 32-bit program, right? So there should be no any hook installed on the 64-bit anti-APIs. So here's a cool idea. It's called Heaven's Gate. because we can assume there's no any hook is placed on the 64-bit. So we can assume the 64 API is clear. It is clear API. We can just directly call them and bypass this kind of detection by anti-malware. So in this kind of trick named Heaven's Gate, we use a lot of steps, just like we are writing a Windows shellcode. So first, we need to get the PEB block, 64-bit PEB block by the GS segment. And from the PEB block, there is an element named LDR element. And this element makes us able to list all 64-bit DLL modules in 64-bit. So we can enumerate all the DLL module and find the NTDLL modules image base. Basically, we get the image base, and there should be a P module is loaded on the image base, DLL image base. So we can check the exporter address table and find the NT API what I want, and we can just call the 64-bit API we want and just call them directly, just like we are writing a 64-bit shellcode. And this kind of attack have been studied about 8 years old or older. From the first post is by Revolve in 2011. This post basically explores this kind of attack. There's more and more people try to make the follow-up study. And I list the useful posts here. I have read them. Those posts is very useful. I use them as a reference. This post try to use this kind of shellcode using attack method. But actually, if anybody try to use those POC, you will find it's very hard, very difficult to use in practice. For example, that's very difficult and not stable enough to use in 32-bit C++. If you try to use 64-bit NT-API and with 64 calling convention and 64 data structure in 32-bit C++ compiler, is very hard to use. This is the first problem to use. And here's another bigger problem is, actually, after the memory layout of WoW 64 process, after from Windows 7 to Windows 8, here's a normal WoW 64 process memory layout. And here's the WoW 64 process memory layout after Windows 8. And you can see the difference. This picture is from DualLab, and you can see the difference between Windows 7 and after Windows 8. And you can see the NTDLL 32-bit and 64-bit is both under the 4 GB. The address is under the 4 GB. So from 32-bit NTDLL or 64 NTDLL module, you can see both of them, the address is very easy to use in 32-bit because the address is totally is under the 4 GB. So it's very easy to use. But the memory is changed after Windows 8. And you can see the 64 NTDLL module have been relocated to a new address above 4 GB. So the address is basically very difficult to use just in 32-bit. It's very hard to use. So it's another big problem. So in this talk, I create a new POC named WoW. Maybe we can just use the translator inside the WoW 64 layer, and we can use the translator directly to simulate every 32-bit into 64, but we can just use it as a new Heaven's Gate. Before we talk about those attack detail, we need to figure out how WoW 64 layer works by reversing engineering. And first one is initialization of WoW 64 process. And here's a function named BT CPU simulated function. And this function basically is an entry function for any WoW 64 process. And you can see on the picture here, basically this function just do only one thing, is call another function named run simulated call function. And it's an infinity loop just to do call this function. And at the beginning of run simulated call function, you can see here, it make a copy of those important registers by just push instruction here, push, and a big pointer is right here. You can see, register R12 was set to address of TEB block, and R15. Register R15 is set to a pointer list named turbo sunk dispatch. So there's a lot of function point will be kept inside of this list, turbo sunk dispatch list. And R13 was set to address of thread context for 32-bit thread inside WoW 64 process. So you can see here, R13 was point to R12 and add offset here. And this offset is kept address of thread context in WoW 64 process. And we just say about the turbo dispatch sunk. This table is a function pointer table. And in this function table, you can see there is a lot of function pointer here. And totally there's 32 different function pointer right here. And only thing we need to know is the last one is CPUP, return from simulated code. And the first one is turbo dispatch jumper address end function. And these two function is most important one in this list. And CPUP return from simulated code. This function basically is from the name. You can see this is a function for 32-bit program when it need to transform into 64. And this is a first copy function from 32-bit to 64-bit. This is a first one copy function for 32-bit to use. And turbo dispatch function jump address end, this function, this is a copy function too, but in this function we'll call the translator inside WoW 64 layer. And if we can access this function pointer, we have known about there should be at least a pointer to the thread context, and there should be a translator inside WoW 64 layer. And two important copy function for 32-bit program. So next part we need to know about is the chamberlain. How to make the 32 system code work into 64-bit. And here's a sample here. You can see when a 32-bit anti-rhythm thread was invoked, and the thread from here will jump into the gauge here. So on this gauge is on the module WoW 64 CPU DLL module. And on this gauge, you can see it basically uses Intel far jump to change the CS segment from 23 to 33, from here to here. So now from here, this line, you can see Intel CPU will treat the following assembly code machine code as 64-bit. So now we can use 64-bit assembly code here. And we just talked about regist R15 is set to the pointer list turbo thunk dispatch. So in this instruction, we have say it will jump into the last one function, cpup return from simulated code, this function. And this function we just mentioned, it is first copy function from 32-bit into 64-bit. And at the beginning of cpup return from simulated code, this function here, and it tries to make a snapshot for the current thread, and the snapshot is set at the regist R13. So you can see here, he tried to keep current EDI, ESI, EBX, EBP. Those registers will be kept on the register R13. And after the snapshot is done, and you can see the thread will jump into the function. Is the first callback function is turbo dispatch jump adjust end we just mentioned, and this function will call the translator function here. You can see this function is the translator function named WoW64 System Service EX, and in this function you will try to use this translator function to help us simulate the system interrupt. It will receive a 32-bit system call number and 32-bit parameter list. And after the API is simulated done, and remember we just have a snapshot on the register R13, it's time to get a recover from the snapshot here. So we can get a recover from the snapshot we just saved and jump back to the return address and continue run into 32-bit program. We keep talking about there's a translator function named WoW System Service EX. So we will get more deeper close to it by reversing engineering. And just like everybody have new syscall number, they actually is 16-bit value kept by the register EX. And basically, they is not just a value, and they actually is a data structure named WoW64 System Service. This data structure I have listed here. You can see in this data structure, the higher 4-bit is syscall table index, and the lower 12-bit is syscall function number of the syscall table. And the internal of WoW Systems Service EX function, we just say the syscall number here, just this argument you can see, we just say this syscall is made of syscall table index and function number. So that is not difficult for us to notice the syscall number. Actually, that is a key of two-dimension array. If you try to use IDAPRO to decompile the system module WoW64 CPU.dll, and you can see there's a function pointer list here named SDWHNT32 jump table, and there's a lot of functions here, and those functions are used to read 32-bit interrupt and simulate those 32-bit interrupt into 64-bit interrupts. So basically, you can see there's a lot of functions, and those functions are used to help us transform our 32-bit interrupt into 64-bit interrupt. So actually, I have just say there's a key here in the argument, first argument. So that we can find a match one function from this jump table by the key. So you can see there's a code here. It does use the syscall table as a key to look up a match one function to use here. Just use it as a key of two-dimension array from this jump table. And if we find a match one function from this jump table, and we can use the function pointer to transform our 32-bit interrupt into 64 interrupt. So we can just at the end of WoW64 system service EX function, you can see it directly use the function we just look up and call it directly, then finish the simulated. So it's very easy, simple design. Just look up a match one function point and use the function point to use it as a function to transform our 32-bit interrupt into 64 interrupt. So let us make a recap, put all the things all together. And if we try to call a 32-bit Windows API, first, it will change the Intel CPU mode from 32-bit to 64-bit by changing CS segment value, and make a snapshot for current thread context at the register R13. Then run into the translator function while system service EX. In here, we can find a correct turbo function from the jump table. They help us to transform our 32-bit interrupt into 64-bit, and we call the turbo function directly. In the turbo function, it will invoke the correct 64-bit NT API, and finally, the interrupt will be sent to the 64-bit kernel and finish the job we want. And after the task all done, and the thread need to get recovered from the snapshot we just create and jump back to the 32-bit program, then continue running. So there are 3 points for us to overuse. First, if we can change our CS segment value, then we can change the we can change Intel CPU to in 32-bit or 64-bit. And there is a register R13 always point to 32-bit thread context. So if we can write into this memory, we can control next program counter will be recovered, and we can control the 32-bit program will jump back to whatever. And finally pointer is there is always a WoW60 system service EX that is used as a translator for us to simulate any 32-bit system interrupt into 64 kernel. So here I'm going to talk about my first POC. I call it WoW Grill. And we have talked about the whole system interrupt running from 32-bit to 64-bit on Windows. And there is a WoW64 layer help us simulate our 32-bit interrupt into 64-bit. And finally, this layer, WoW64 layer, will call the correct 64-bit version NT API to finish our behavior. And however, after reversing engineering, we have new there is a translator function just inside this WoW64 layer. So actually, this translator function named WoW64 System Service EX that is made by Microsoft and stable enough and easy to use. So here's a cool idea. And this cool idea is if we can locate this translator function, and actually we can send our 32-bit syscall to it directly. And in this POC WoW Grill, I use a Windows shellcode trick to locate this translator function in 64-bit and send our syscall request to it directly. And actually, we don't need to use the old path might be checked by the antivirus. So here is a simple demo, and this demo is totally open source project for you guys to test here. And here's an easy demo for here. And you can see, I install antivirus here, and I update it to the latest. And in the protection, I have enabled the heaps protection, and real-time file scan protection is enabled too. And first, I use a typical malware behavior. Process hollowing is run PE, and you can see this antivirus can detect it directly and remove this malware file. But if I change those Windows API inside the run PE, then you can see I use this kind of new trick, WoW grill, and try to make our pickable exe file be process injection into character exe file. And you can see here our process hollowing is successful. We can injection our malware file into system program, and the antivirus not able to detect it. So it's a first demo here. Let's talk about the next one. And the final POC, I call it WoW injector. And that is also an injection trick, but the difference is it didn't bypass the hooks installed by antivirus, but not able to be detected too. And this workflow we just talked about before, and that is a full execution flow from 32-bit to 64-bit and back to 32-bit again. But here, the interesting thing is the thread running from 32-bit to 64-bit. It will save a snapshot on the address of register R13, and the address is also recorded on the 64-bit version of TEB block. And after 32-bit interrupt get finished, the thread will fetch the snapshot from the register R13 and become back to the previous thread status and continue running a 32-bit program. So that if we can leak the address of the snapshot, and we can write the snapshot too, and we can also change the next return address to a new destination. For example, we can change it to a new destination like shellcode. So we have said that snapshot is recorded on a 64-bit version of TEB block, right? So the lucky thing is when the WoW 64 process is created, during the kernel function mi create PEB or TB, this function will allocate a large memory and divide it into 4 blocks, TEB 64, TEB 32, and PEB 64, and PEB 32. So that if we can leak one of the 4 blocks and the address of the other 3 blocks also predictable too. So if we can leak address of 64-bit TEB block, and we can also get the address of snapshot too. So here is a final demo here. I call it WoW injector, and here is the link to the GitHub here. Let's see the demo. And here is the demo of WoW injector, and here you can see is the latest Windows version, and I update it to the latest version of anti-malware. And it will need to take some time and install the final signature of malware. And I check the module of anti-malware is the latest. And here I enable the full heaps potential on this victim, and I try to use wget command to get a mimicized malware, drop it into this victim. And you can see when I try to download a mimicized malware into this victim, and here you can see after I drop the malware mimicized into this victim and execute it, and you can see this anti-malware will detect it and remove it immediately. And you can see if I try to use this kind of trick, WoW injector, to injection this MSG box exe file. So you can see I use WoW injector to do process hollowing. I use this injector to do process hollowing into the notepad exe file. And you can see I can bypass the whole heaps potential. And I injection this MSG box exe file into a notepad. So I want to try if mimicized malware will be detected. But if I drop it from the network and injection it directly into a system program, and you can see here, and I use this kind of trick to injection it into a CMD exe file. And here you can see basically mimicized malware cannot be run on this antivirus victim. But here, if I try to use this kind of injection trick and download mimicized payload, injection it into the victim, and you can see mimicized is able to run and not to be detected on this victim. Totally bypass the anti-malware's heaps potential. So here's the final demo. Okay. So if anyone get any question, it's my pleasure to answer, and contact me by mail or Twitter or Facebook. Thanks for listening.